This question asks you to think about how the NCOMPONENTS parameter affects the Nystroem method in Sklearn, a powerful tool for speeding up machine learning. I'll walk you through each part. While generally true, increasing NCOMPONENTS doesn't always mean better accuracy. There's a point where adding more components provides only a tiny improvement but costs you a lot more in computation time. It's a trade-off, right? This is definitely true. More components mean more calculations, which slows down the process. Think of it like this: if I want to draw a detailed picture, it takes more time. Absolutely. The whole point of Nystroem is to speed things up by using a smaller sample. Making NCOMPONENTS almost as big as the full dataset makes it slow. It defeats the purpose of approximating the kernel. You got it. Using only a tiny subset of your data is like trying to understand a whole book by only reading the first 5 words. You'll miss most of the story, and the same goes for approximating the kernel. This gives the context of your data. You have 1,000 data points, each with 50 measurements. This information helps you decide the best value for NCOMPONENTS. The larger the dataset, the more relevant the effect of NCOMPONENTS becomes. The problem sets the stage. We are using Nystroem, a technique in Sklearn to make kernel methods faster. I'm using the Nystroem method, a technique that cleverly approximates a kernel matrix to speed up calculations. The core parameter I'm focusing on is NCOMPONENTS. This parameter determines the size of the random subset of my data used for the approximation. This question tests my understanding of how the NCOMPONENTS parameter affects the Nystroem approximation. I need to evaluate the accuracy and computational cost trade-offs. If I set NCOMPONENTS to a value very close to the number of samples in my dataset, I'm essentially using almost all the data. This defeats the whole purpose of using the Nystroem method for faster computations. It's like trying to take a shortcut by walking the whole distance. Increasing the NCOMPONENTS value means I'm using a larger subset of my data for the approximation. This will undoubtedly increase the computation time. It's a simple cause and effect relationship. If I use a tiny NCOMPONENTS value, I'm only using a small fraction of my data for the approximation. This will lead to a significant loss of information, resulting in a poor and inaccurate approximation of my kernel matrix. Think of it like trying to describe a whole landscape with only a few pixels. That just won't do. The Nystroem method is a clever technique that speeds up kernel methods by approximating a large kernel matrix using a smaller subset of your data. The _n_components parameter controls the size of this subset. Think of it as choosing a representative sample from your data to work with. I agree. A larger _n_components means I use a larger subset of my data for the approximation. That means I have more computations to do, which naturally increases the computational cost. It's directly proportional. Exactly. If I set _n_components to almost the same number as my samples, then I'm essentially using the entire dataset for the approximation. The whole point of the Nystroem method is to gain speed by working with a much smaller subset, making this a pretty pointless exercise. It's like trying to save time by taking a longer route. That's right. If _n_components is too small, I'm losing critical information about the data when I create my approximation. My approximation will be inaccurate and won't capture the essential patterns in the data. Imagine trying to understand a whole country by looking at only a small village. I'm using the Nystroem method, a clever technique to speed up kernel methods. It works by approximating a large kernel matrix using a smaller, carefully chosen subset of data. The key parameter here is _n_components which controls the size of this subset. If I use a large _n_components value, I get a super accurate approximation. However, I also pay the price in computational cost. It's like using a really detailed map, very precise but takes longer to work with. A medium n underscore components value is a sweet spot. I get a reasonably good approximation without the hefty computational burden. Think of it as having a detailed map with enough information, but not to the point of overkill. Using a small n underscore components value means I'm using a smaller subset of data for the approximation, so computations are fast. However, I lose accuracy. It's like using a very rough sketch instead of a proper map. We're using scikit-learn's Nystroem method to speed up a kernel method. Think of it as a shortcut to make calculations faster. The Nystroem method uses a smaller subset of the data to approximate the full calculation, allowing you to save computational time and resources. The parameter n underscore components controls the size of that subset. I have 1000 data points, each described by 50 features. This is the data Nystroem will work with to find an efficient approximation. This is the core question. I will examine a few statements about how n underscore components the size of the subset of data that Nystroem uses, affects the accuracy and speed of the approximation. If I increase the size of this subset, n underscore components the calculations will take longer. This is always true. A larger subset means more calculations for the Nystroem approximation. Setting n underscore components to be almost equal to the total number of samples negates the benefit of using Nystroem in the first place. It's like taking the long way instead of the shortcut. This is also always true. If I use a really small subset, I lose a lot of information, so the resulting approximation is bad. This statement is always true. It's like trying to summarize a whole book with only a few words. The Nystroem method is a clever technique I use to speed up kernel methods. Imagine you have a huge dataset, and calculating everything takes forever. Nystroem lets me approximate the kernel matrix using only a smaller part of the data, making things much faster. It's like summarizing a long book with just the key chapters. The n underscore components parameter controls how much of the data I use for this approximation. It dictates the size of this smaller subset. A higher n underscore components means I include more data, leading to a more accurate approximation but at a higher computational cost. Conversely, a smaller n underscore components means a faster calculation but possibly a less accurate result. I'm working with a dataset containing 1000 samples and each sample has 50 features. This is the information I'll use in the Nystroem approximation. The quiz is about understanding how the parameter n underscore components in the scikit-learn's Nystroem kernel approximation affects the accuracy and speed of the computation.